All right, welcome to part 3 of the PowerPoint. You have 3 parts to this PowerPoint, and your quiz will have 4 questions representing 1 question for each part of the PowerPoint. Okay, so in this part of the PowerPoint, I'm going to teach you how to write something called a thermochemical equation. So you should be familiar with recognizing a chemical equation because we balanced some chemical equations in Unit 1. So you did something like this. Okay. So you are used to seeing a chemical equation. It has reactants on one side, right? Reactants, and it has products on the right side, and it is connected by the arrow. Um, that means the reactants react to produce the products. Okay, so that is what you're used to. Now, the way to make this a thermochemical equation is to literally do that. Include a term in the equation that represents thermal energy, okay? And we call that the enthalpy value. If you remember from a previous discussion of enthalpy, enthalpy represents all of the heat in the reaction, right? So if you include an enthalpy value in this chemical equation, you now have a thermochemical equation, okay? Recall from the previous lecture that if your delta H, or the change in enthalpy, is positive, we are talking about an endothermic reaction, which is a reaction that absorbs thermal energy, right? And if your delta H is negative, we are talking about an exothermic reaction that is releasing energy. So a fire would be an example of an exothermic reaction. And let's see, water or ice melting would be an example of an endothermic process. Okay, ice absorbs energy to melt, so entering energy means endothermic thermal energy, and exiting thermal energy means exothermic. Okay, delta H is the change in enthalpy, and positive for endothermic, negative for exothermic. Okay, now here is what I was talking about. Here is the chemical equation. You should recognize this from last year. This is the equation for respiration. You have glucose and oxygen, which are the reactants. They're combining to produce carbon dioxide and water. So that's just the plain chemical equation, okay? The way that you make it a thermochemical equation is by including this term in orange right here. That is the enthalpy for this reaction. That makes this reaction now a thermochemical equation. Okay? Enthalpy term has to be included in order to make it a thermochemical equation. So, in this unit from now on, you will get reactions that include the term for energy. Now, I'm going to teach you how to read this. So, you can read this thermochemical equation in terms of all of the reactants and products that are present. So I will make the reactants blue and I'll make the products green. Each of these components, the glucose, the oxygen, the carbon dioxide, and the water, has its own relationship with this energy term. Okay, so here's how you read it. If you read it in terms of the reactants, which are the blue things, you can read it as when 1 mole of glucose is reacted in this reaction, 2044 kilojoules of energy is released. And you might be like, Monsieur, where did you get the 1 mole from? The answer to that question is the mole comes from the coefficient in front of the reactant or product. So you see how glucose doesn't have anything? That means there's 1 mole of glucose. See how there's 6 in front of the O2? Those are the coefficients that you learn how to use to balance equations, right? That 6 is 6 moles of O2. This is 1 mole of glucose. Okay, this is 6 moles of CO2. This is 6 moles of water. So we assume that the coefficient has the unit of moles built into it, okay? And then this unit is kilojoules, which is the unit for energy, right? That's a convenient arrow right there. So you can read it as When 1 mole of glucose reacted in this reaction, 2044 kilojoules of energy is released. And the reason that we say released is because there's a negative sign right there. Negative sign indicates energy being lost from your reaction, right? So released into the environment, okay? If you read it in terms of the products, you can read it as when 6 moles of carbon dioxide is produced in this reaction, 2044 kilojoules of energy is released. Okay, so each of these components have a relationship with the enthalpy term. Now, if you have a relationship with the enthalpy term, that means you can write conversion factors, right? So look at the way that these relationships have been written down. Here's glucose, here's the energy. The way that you write the relationship between these two components is to make it an equality right there. 1 mole of glucose is equal to negative 2044 kilojoules of energy. 6 moles of CO2 is equal to negative 2044 kilojoules of energy. The amount of energy stays constant even if you are changing the reactant and product associated with it, okay? You can also write two more things. I can write it in terms of the oxygen, right? What if I do this, and this? Then I would write 6 moles of O2 is equal to negative 2044 kilojoules of energy. What if I write it in terms of the water? We don't want water to feel left out, right? 6 moles of water is equal to negative 2044 kilojoules of energy. Now, I have 4 equalities for the same reaction, and in all of them, the amount of energy has stayed constant, okay? Now, remember from Unit 1, if you have an equality, you can write conversion factors. If you can write conversion factors, you can do dimensional analysis, okay? So here's my equality. Quick review on how to write conversion factors. Remember, you can write 2 of them. And what you do is you switch, right? I don't want to put 1 and 2 there because it seems like I'm labeling those things. Here's how you write conversion factors. 1 mole of C6H12O6 over the right side of the equal sign, which is negative 2044 kilojoules, or negative 2044 kilojoules over 1 mole of C6H12O6. What if it was for the carbon dioxide? I can do the same thing. 6 moles of CO2 over negative 2044 kilojoules of energy, or negative 2044 kilojoules of energy over 6 moles of CO2. You can also do the same thing for the oxygen. 6 moles of O2 over negative 2044 kilojoules of energy, or the opposite of that, negative 2044 kilojoules of energy over 6 moles of O2. You can literally take each reactant and product, write an equality with it like this. There's 1, 2, 3, 4 equalities, and for each equality, you can write 2 conversion factors, okay? So, if you can write conversion factors, remember, you can do dimensional analysis. So that's what we're going to do. Instead of having simple units like meters and centimeters and grams and milligrams or whatever, the units that we are looking at are moles and kilojoules. So I should be able to go from moles to kilojoules or from kilojoules to moles. And that is what we're going to use these conversion factors for, okay? So let's look at a problem. Here's the first problem. How much energy is released when 4 moles of glucose reacts according to the following equation? So I have this chemical equation. You might be like, where do I start? You start by reading the problem, okay? It says 4 moles of C6H12O6. So you write that down. 4 moles C6H12O6. Then you write your multiplication sign, your line, your equal sign, and the question is asking for how much energy. So we know that our answer must be energy, and the answer is going to be kilojoules. All right. Now, remember, you can write conversion factors that we just did. And you might be like, wait, what do I write conversion factors for? You're writing for glucose's relationship with the energy term. Okay, so here is your equality. 1 mole of C6H12O6 is equal to negative 2044 kilojoules of energy. Okay, that's your equality right there. So here are your conversion factors. 1 mole of C6H12O6 over negative 2044 kilojoules, or negative 2044 kilojoules over 1 mole of C6H12O6. So look at that. Now that we have two conversion factors, you just apply the principles of dimensional analysis to this, which is you use the one that helps you cancel out the unit you don't want and get to the unit you do want. So you want to cancel out moles of C6H12O6 and you want to go to kilojoules. And the unit or the conversion factor that allows you to do that kind of unit cancellation is this one that I just labeled number 1, that has negative 2044 kilojoules on the top, 1 mole of C6H12O6 on the bottom. Moles and moles cancel out. 4 times 2044. Let's calculate. Will give me negative 8,176 kilojoules of energy. Okay, basic dimensional analysis, but using a chemical equation. All right, don't get lost. Read the problem carefully. Then look at the two things that you have to look at, the energy term and the compound in the problem. Then you make it equal to each other. Then you write two conversion factors, and then you solve for the unit you want. Okay, super simple. Let's do this question. If negative 597 kilojoules of energy was released, how many moles of glucose reacted according to the following reaction? So start by writing the number down. Negative 597 kilojoules of energy is reacting. You need your multiplication sign and your line, your equal sign. It's asking you to go to moles of glucose. So your units at the end should be moles of C6H12O6. Okay? Again, it's asking you to look at glucose, C6H12O6, and the energy term. You make that equal to each other. 1 mole of glucose, C6H12O6. Again, if you've forgotten, it's 1 mole because the coefficient in front is 1. Negative 2044 kilojoules. Write two conversion factors, 1 mole of glucose on the top and 2044 kilojoules on the bottom, and switch it. Negative 2044 kilojoules on the top, 1 mole of C6H12O6 on the bottom. Now let's see, what do we need to use? This is 1, this is 2. I want to cancel out kilojoules. I want to go to moles of glucose, so I'm going to use the first conversion factor, 1 mole of C6H12O6 on the top, negative 2044 kilojoules on the bottom. Kilojoules cancel out, negative and negative cancel out. So 597 divided by 2044 will give me 0.292 moles, okay? The negatives will cancel out to give us a positive value for moles, because moles is basically stuff, right? You can't have negative amount of stuff. So negatives have to cancel out. Make sure you follow that. You solve it the same way, okay? All right. If you have any questions, pause the video, go back, re-look at it. That's how you learn, okay? Pause the video, go back, see where you have questions. Either email me or just play it again and see where you're going wrong, okay? And then try the problems on Canvas.